In this video, I'll demonstrate creating a midpoint Riemann sum for an integral. The first thing I'll do is draw the function. Next, I want to list all my 5 rectangles. Alright, so according to the problem, we need 5 rectangles. Let's calculate the width of each rectangle with the formula b minus a over n. Our a is 0, our b is 5, according to the limits of the integration. And we want to approximate the area under the curve. Each rectangle has a width of 1. So I don't know how tall the rectangles are going to be yet, but I'll just show the boundaries between them. Now the toughest part is going to be to find the x value with which we want to calculate the height of a rectangle. In a left Riemann sum, we had used the left side of the rectangle as the x with which we would plug into the function and get a height. In a right Riemann sum, we would take the right side of the rectangle and use that to find the height. Since this is a midpoint sum, what we want is we want to use the middle of the rectangle to calculate the height of the rectangle width. So that black dot here is actually going to be my x1. And the black dot here for the second rectangle will be my x2. And so on. Now the numbers with this one aren't too tough that we can just figure out what those values are. Our x1 is going to be 0.5, halfway between 0 and 1. x2 will be 1.5. x3 will be 2.5. And we'll have 3.5 and 4.5. Alright, so next we'll need to figure out how high these rectangles need to be. In other words, what is the function's value at those different inputs? So a new column will be for f of xi. So here we're going to get 0.5. 1.5, 2.5, and so on. And those will be our heights. Now our job is to sketch the rectangles. And we could shade them in too. Okay. That's a good picture of it. Okay, so now let's do a column for delta x. The width of the rectangles is all 1, according to this right here. And then we just need the area of each rectangle. So multiply, and we'll get 0.5, 1.5, and so on. All right, let's label each of those areas above their respective bars here. Okay, great. Now we can add them all up. And we're going to get 12.5. And so the basic theme here of these Riemann sums is that we can approximate an integral from a to b of f of x dx by using a summation from I equals 1 to n of f of xi delta x. We should see a little bit of similarity between these formulas. And so n is the total number of rectangles, and that can actually vary depending on the person doing the Riemann sum. Now let's go ahead and look at a useful online web application for calculating Riemann sums. If I search for Desmos Riemann Sum Calculator, then it'll come up in a search engine. And what it's going to do is it's going to create these bars for you. Now this is just a example function that they have. We're going to change the function. Let's change it to our function, which is f of x equals x. Okay, this looks like a left Riemann sum right now. The interval is from -1 to 3. So let's go ahead and change the interval to match our interval, which was from 0 to 5. Okay, I'll zoom out a little. All right, it looks like they're using more rectangles than we had used. If you scroll down, you'll see that, yeah, they're using 12 rectangles. So let's use 5, just like we had in our problem. Okay. Now this is a left Riemann sum. And you can actually control whether you're doing a left, right, or a midpoint Riemann sum with this next slider here. They call it C. If it's set to 0, you're going to do a left Riemann sum. You can move it over to 1 in order to do a right Riemann sum. And then if you scroll down, you can see the results. 15 for a right Riemann sum. It's 10 when you do a left Riemann sum. Now let's switch it to 0.5. That's the midpoint sum that I had just calculated. and it tells us the answer is 12.5. So it's just a good tool to use to check your work.